And
Are we?
I plugged my computer in, like hardwired to the internet, so hopefully the internet won't go out on us.
All right. We'll pull up.
I apologize for my dog snoring.
He's snoring.
Because she, like, none of her favorite people are here. So she's come to the next person. And so she's just sitting over here right next to me with her sleep apnea and snoring.
Okay, so did you guys have trouble?
For the most part, I was able to figure it out.
I had to do it many times. I had to watch the videos.
That's what I do, and that's what gets me through it. Because I read the chapters, but at the same time, I'm like, I need a hands-on. I need a rationale.
Mm-hmm.
After I watched the videos, I felt better.
So part 2 of this one has like an activity where we're supposed to cut out the squares and draw 5.
Well, you don't have to do that.
What was your mean? I think that's what we need to determine what everybody's mean was. I think that's what they decided.
Right. So my mean was 45,140. Was yours something like that?
Mine was. Oh, go ahead.
You go.
Mine was 48,780.
Mine was 47,240.
Yeah.
So we were like all within a couple thousand there.
And I was actually
was supposed to happen.
Yeah. So then the question was, make a mark on the graph, and my graph was like near the middle, and it was my
too.
Mine was normal.
Okay, so we're all cool with that, and then you guys were okay with question 8?
Yes.
Okay.
Yeah.
I'm nervous because I did this on Sunday and I haven't really looked at it, so but I guess I could take the quiz.
Sounds good. I know. We're just gonna make it work, right?
Yep. Okay. So I'll minimize this and go to the quiz.
It looks like we'll need the applet. Oh, I'm sorry, I'm yawning so much. It's kind of embarrassing.
Okay. Thank you, honey. I have one. Thank you. David just brought me dinner.
Oh.
Did we use the applet for 6?
I didn't remember us doing it.
Let's probably review or something. When calculating anything.
Never mind, I'm not going to say anything.
Okay.
If needed.
Yeah, we'll see if we need it.
Round to 3 decimal places.
Alrighty. So question 1 says, question 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of the program when the parent population is right skewed? So there was one kind of like that on homework.
Yeah.
And it was because, I don't know, according to the rules, I think and correct me if I'm wrong, I think there's a possibility that it could be skewed right.
I think so too.
So here's
because the sample size is 5.
That stuff never made sense. That wasn't on the preparation.
Okay, so what it is it's those rules. It's the rule of large numbers and the central.
Yeah.
Those things. So what she's saying is that if you know that the distribution was right skewed and you have like this small sample, It's going to be skewed right.
Whereas I think if it was greater than 30, it'd be normal. Is that your understanding of it as well?
Right, because then I'm looking at the homework, and the next question was the distribution was right skewed, but you had a sample size of 100. So the larger the sample, the closer normal it gets.
Because I know that. So like the larger the sample, the closer it is to the population number.
See, here's this. Look at question 4. It's the same thing. It's asking you, even if it's right skewed, now we have a sample of 100.
Right.
So it's going to be
the bigger the sample, the more normal it is. So because this is the small sample and it's the parent population is right skewed, it's going to continue to be right skewed or skewed right.
On the smaller sample?
Yes.
Yes.
Is that what you're saying?
Yes.
Yes. Well, and with that group collaboration with part 2, you know how we had to graph it and get the mean? It was more so normal and closer to the middle. I feel like it kind of follows those same guidelines.
Yes.
So we're agreeing on skewed right.
Yes.
I agree.
And then for question 4, normal.
Because it's the larger number, even though it's right skewed.
Yes.
Right.
I feel like the homework kind of prepares us.
Well, I did the homework, and those were the questions that I just kind of scratched my head and moved on because it hurt my head.
I'm so glad they give us the answers because it really does help.
So that you can at least like figure out what you're doing wrong, you know, give you a chance.
Exactly.
So when you're taking a sample size of n equals 5, what's the shape of the distribution of means histogram when the parent population is normally distributed?
Normal. Yes?
I think so.
Because I thought it was if the parent population is normally distributed,
it's going to be normal.
The question was, when is the distribution of sample means normal? When the parent population is normal or when the sample size is large.
Okay. So it's one of those two.
Yes. So because our parent population is normal, then our the shape should be normal.
Do you agree, Gwen?
Yes.
Okay.
Okay. Yes.
Gosh, these are a lot of the same question.
So this, I'm like, well, thanks for, because this was the one part that I felt
solid,
not prepared for. No, this part.
Oh.
Okay, so when you're taking the sample size of n equals 100, what's the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
Normal still.
Yes.
And then 7, when would the distribution of means be normally distributed? Choose all correct responses. The population is normal and the sample size is small or large.
It feels like it's large.
But
I think I'm wrong too.
I agree, except that they're both normally distributed populations, so it should be both of them.
Because I have notes on that video and like the key points. It was saying when is the distribution of the sample means normal when your parent population is normal. So
or when the number is large.
Or when the number is large. So the first and second options have a normally distributed population. So those are automatically yes. Those are true.
It's the answer to number 6 in part 1. It says X bar is normally distributed if the data were drawn from a normal population or if the sample size is sufficiently large. Okay. So even a small sample drawn from a normal population should be
normal.
Normal.
So what's the second? It's C is not correct.
C is incorrect. That is not true. But I think D is correct because it's right skewed, but it's a large sample size.
Oh, I almost didn't pick that one. I think you're right. The sample size is large.
I'm looking for keywords.
Perfect.
So A and B have a population that is normally distributed, so those are true. And then D has a large sample size, which makes that one true.
Okay.
But C is not. I hope.
Okay.
We'll go for it.
Which of the following gives the best explanation of the central limit theorem? Okay, I'm gonna pull it up in front of me. Got it.
These confuse me because they're so similar.
It's, I think it's D. Let me see. Because I'm looking at the definition from the, the answer key. And it says the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed.
And that's what it says.
And
keywords approximately normal. I agree.
Because I know 2 is not it, and 3 is that's the rule of large numbers.
Yes.
Okay.
Good.
Use the following information. Let X be a random variable with a population mean of 10 and the population standard deviation of 6. Suppose a sample size N36 is drawn from this population. Oh my gosh, I have to do math.
So isn't it the mean divided by the standard deviation square root n?
Yes.
Okay.
So the mean is 10?
Yes. That's when our fancy calculators help out.
Wait, I did that wrong. Oh my gosh, I'm so tired. So you set up the problem, it's 6 divided by the square root of 36, right?
Yes. What did you guys get?
Shh. Uh-oh, Megan got kicked out.
Oh, dang it.
Let me see. It should be.
I was kicked out.
Are you back?
Yes.
Okay. Shouldn't it be 1?
Which question?
What's the square root of 36? 6?
All right, friend. 6.
It's
So question 8 was C, right?
D.
Wasn't this a homework question?
It's asking about the rule of, it's asking about the central limit theorem. So the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed.
Oh, hold on.
Gwen, what did you get
Yeah.
for 9?
I got 0.277.
What did I do wrong?
So this is what I did, and I got the same answer both times.
Okay.
6 times 6 is 36, right?
Yeah.
I don't really care.
And then I did 10 divided by 36.
It's 10 divided by 36.
And it was 0.277. And then if you set it up on your calculator, like you did it as a math problem that you set up, and like I had to do this. I don't know how your calculator works, but it's like 2 arrows.
Isn't it the standard deviation divided by the square root of the sample?
I was gonna, the mean of isn't this where we're supposed to do?
what I'm saying is, shouldn't it be, and tell me if I'm wrong, but shouldn't it be 6 over the square root of 36?
That's what I did.
Look at my paper and see if that's what.
Because I think the standard deviation goes over.
So it's 10 divided by 6 square root of 36.
Right, but the standard deviation is 6, and the mean is 10.
Did I do it wrong?
You put the mean over the sample instead of the standard deviation on top.
Because I think it's supposed to be, here, I'll put it up on,
Okay.
it's supposed to be that. You can't really read my writing, isn't it? 6 divided by the square root of 36.
Find the
Oh, yes. You were right. Maybe I'm jumping a few steps ahead somewhere. Yes.
My thing is like, this is what drives me crazy about these classes is I don't remember anywhere in the preparation or the homework where it says let X be a random variable.
You know what though? You might be right.
That's what I'm.
Hold on. What is the mean of the distribution of sample means? The answer, it's 10. The answer is 10.
Yes.
We're overthinking it.
Dang it.
Remember, because the mean of the
mean is 10. The standard deviation is going to be 6.
right, but the question is asking you, it's the same as question 8C, where we know that the mean is 529. We gave that to you. And then what is the mean of the sampling distribution of sample mean scores for all such samples? This is like tricking us, because the population mean and the sample mean, it's that thing where X bar equals X, like they're the same. Or it, you know what I'm saying?
Yes, I'm trying to.
So if you look
It's
at
the mean of distribution of sample means equals the mean of the parent population.
right, there it is.
So this answer is 10.
Okay, okay. So the sample mean is 10.
Yeah, that's what they're asking. We haven't had to do math yet, but we were doing a really good job at trying. Like, all we had to do was look at the mean for that answer. Does that make sense?
Yes.
No?
What is the mean of the distribution of sample? Yes, it does. It is a trick question. Whoa.
Yes. Now this is where we do math. And the answer is 1, I think.
That's what I got too. That's a good one.
Jeez Louise.
Roxana.
There was one of the homework quizzes or something that I did, and I got an answer wrong, and it was totally just because I was reading the problem wrong. And I racked my brain about it for days.
That's hilarious.
I feel like this quiz is just trying to beat an idea into our heads.
Yes.
Let's look at question 11.
I was like, is A? Is
Yes.
normal?
Yes.
I don't know what bimodal is. Don't throw in new words I haven't read before.
I'm just looking at greater than 30 with the population. Then it said it would be normal. Because bimodal, if I think I remember, it's like all the way straight across. And normal is like that little whoop-doo-woo.
I think 12 is central limit theorem. But I might be wrong.
Okay. Let's look.
The central limit theorem describes what happens to the shape of distribution of sample means when the sample size is large.
I think that I agree with you, Melissa.
because the central limit theorem is about more about the shape, and the theory of the large number theory. I'm saying it wrong.
The law of large numbers.
Yeah, the law of large numbers is more about accuracy, right?
Talks about the spread of distribution.
Okay, I'll be the sacrifice and turn it in first.
Sacrifice.
Skewed right, normal. I just want to make sure I put everything in. Okay. 100%, friends.
Woo!
On our first try.
Nice.
We can do hard things.
We can.
Nice.
Less painful. Because the first time I had to get up early, because I worked last night. I had to wake up early and do this over again because like the first 2 times I went through it, I was just like, what?
I had to look at it like 3 times. Thankfully, it was a short lesson because I had to look at it like 3 times.
Yes. So, are we thinking? When are we thinking?
Well, I think everybody had said
Thursday
again. I mean, I know it's kind of last minute, but because I hope Kelsey's okay, but I know she has new beginnings tomorrow night.
Mm-hmm.
So what are you thinking?
I can do Thursday. What time on Thursday were we thinking?
I don't work. So any time for me. I don't know about Megan. Do you work Thursday?
I don't work Thursday, so
I work Thursday, but I'm almost guaranteed I will be done by 1700. So 4 o'clock your time?
Yeah.
I should be done. So would that be, I mean, I'm sure you guys have dinner. So anytime after 4 o'clock your time I could do.
Okay.
Are you working on Thursday?
Me?
Yeah.
No, I was thinking about taking Joey to the movies because it's the last day The Greatest Showman is in theaters.
I want to see that.
So
maybe I'll go tonight.
I could go after the meeting too because there's a 7:10 showing. So do you guys want to do like 4? Or do you want to do 5?
What time for you guys?
So that we're talking like 5 or 6 for you.
5 our time. Yeah.
I could do 6.
Is that okay?
Yeah, so it'd be 5 your time and 6 my time.
Yeah.
Yes, I could do that.
Okay, and then we'll see if we hear from
I know.
Kelsey. I hope she's okay.
Thanks.
I'm sorry. We said
5 o'clock our time.
5 o'clock California time.
Mm-hmm.
Yeah, and 6 o'clock Arizona.
Okay. And then if we hear something different from her, we can do something different. But
yeah,
I hope she's okay.
I know.
I know.
All right, guys.
Okay, thank you. Strong work.
Thank you.
See you Thursday.